Welcome to the third and final video in lesson 4-2. So far we've talked about multiplying radicals and we've talked about simplifying radicals. Now it's time to put those together. So we're going to go back and revisit some of the examples we looked at in video 1. At the time we multiplied them together, but we didn't look at simplifying them at all. Now that we have that tool in our tool belt, we're going to go ahead and multiply them and then go ahead and simplify them as well now. And this is what you'll need to do anytime that you are multiplying these problems out from here on out. So, we're going to review this example that we started with, 4 square roots of 3 times 5 square roots of 8. Remember that we are going to multiply together our coefficients, and we're going to multiply together our radicals, or our radicands, sorry. So we said that 4 times 5 is 20, and then we said that 3 times 8 was 24. And at the time we stopped there and we said that we would simplify it later. Well, now it's later, so let's go ahead and simplify it now that we know how. We're going to take the radicand of the 24 and we are going to break it down into a factor tree. Now I'm going to give you guys a hint on this. Think about how we got the 24 to begin with. We got it from multiplying together 3 times 8. So I am going to use those to start my factor tree. Now this might not seem like a big deal with a small number like 24. It's pretty easy to figure out numbers that multiply together to give you 24. But when we get into some of the bigger numbers, it's going to be harder to find the factors, and this will give you 2 factors that you know for sure will multiply to give you that radicand. So let's go ahead and continue on. The 3 will not break down further, so we're going to leave it as a 3 and we're going to circle it. 8 could be written as 2 times 4. 2 is as simple as we can go there, so we'll circle it. And then 4 will break down into 2 times 2. And we've simplified everything as far as we can go. So now we're going to rewrite our radicand using our factor tree. Instead of having a 24 underneath, we're going to have the 3 2's that we circle. And we are going to have the 3. Remember, our next step was to find pairs. We have a pair of 2's. And then our 2 and our 3 do not pair up. So our square factor is going to be our 2's here. Now we need to break this up and rewrite it as a different set of radicals. One thing that we did not see earlier on is when we had a number that was already out in front here. It's going to be real easy to deal with. All we're going to do is when we're writing out our square roots and breaking it apart is we're just going to leave this as 20 times our radicals. All we're doing here is saying that that's a coefficient of 20 times the radical. We're going to put the 20 out here times whatever our new radicals are. So we take the square root of our non-square factors, which would be 2 times 3. And then we're going to take the square root of our square factors, 2 times 2. We are going to pull the 2's out. The square root of 2 times 2 is going to be 2. Now the thing that's going to be different here, we're pulling the 2 out, but we already have a 20 here. So all we're going to do differently is multiply those 2 together. Real simple, we're just going to do 2 times 20. And then underneath here we had 2 times 3, which is going to give us 6. On the outside, 2 times 20 is going to give us 40. So our final answer is 40 square roots of 6. And we have simplified our multiplication. This is what you will need to do from here on out. You will need to go ahead and simplify it to its simplest form. That way that you can get the most complete answer. Alright, let's take a look at example 2. You'll remember this from video 1 as well. We have 5 times the square root of 5x times the square root of 3y squared. Remember we established that there's an invisible 1 chilling out there. So on the outside, we're going to have 5 times 1, which is going to be 5, and we'll write that on the next step. And underneath, we're going to have 5 times 3 times x times y squared. On the outside, just like we said, it'll be 5, and then underneath it will be 15xy squared. We need to break down our factors for the radicand. Remember, for 15, we got from multiplying 5 times 3. Now, both of those are as simple as possible, so we're just going to leave 5 and the 3. We'll come back to those later. X is just by itself. We don't have anything that can multiply together x, so we're going to circle that one. And then y squared is y times itself twice. So we're going to include two y's underneath the radical. So we're going to come and rewrite this. We still have the 5 on the outside. Underneath, we have the 3 and the 5 we circled. We have the x, and we have the two y's. We want to look for pairs. In this case, our only pair are the y's. So I'm going to break this apart. I have the 5 that's hanging out outside. I have my non-square factors, which is 3, 5, and x. And then I have my square factors of y times y. I'm going to simplify. Remember, we pull out the y from here, and it's going to come out front. So we're going to have y times 5 times the square root of our non-square factors, 3 times 5 times x, is going to give us 15x. Now, to just clean this up a little bit, we're going to rewrite this as 5y, and then we're going to have the square root of 15x. And that is our simplified answer. All right, give an attempt on these U-tries. Remember to check your solutions on the website, and then go ahead and complete the practice. And when you're ready, collect a mastery check. All right, see you guys in the next lesson.